you're all doing well. In this video, we are going to be looking at a couple of problems involving sequences and series, okay? Arithmetic progression, geometric progression, etc. The first question that we have is, if the sum of n terms of an arithmetic progression is given by 2n square, then the fifth term of the AP is what? Okay, if the sum of n terms of an AP is given by 2n square, the fifth term of the AP is given by what? Okay, very easy sum. The simple way of doing this is we just have to apply one simple logic over here. Now, look at this. I'm going to be having an AP, okay, arithmetic progression, which is going to have a number of terms. Let's say here they're asking us for the fifth term. So let us have 5 terms. The first term of the AP is given by A. Let us denote the first term of the AP as A. All the consecutive terms are going to have the same common difference denoted by D. Okay. Now we know that in AP, every consecutive term is going to have a common difference over the preceding term, which we usually denote by the term D. Now, so the second term is going to be A plus D. Third term is going to be A plus 2D. Fourth term is going to be A plus 3D. And fifth term is going to be A plus 4D. If I add all of this, okay, if I add all of this, they are saying that the sum to n terms of this arithmetic progression is given by 2n square, okay. So, the sum to 5 terms, S5, will be given by 2 into 5 square, because n is equal to 5. So, that gives me 2 multiplied by 25, which is nothing but 50. Okay. Now, they are asking me to find the fifth term of this AP. I have the summation to 5 terms over here. Okay. S5 is equal to 2 into 5 square is equal to 50. Now, if I take the summation up to 4 terms of this arithmetic progression, S4, okay, S4, applying the same formula, 2n square, I'll be getting 2 into 4 square, because n over here is 4. Okay, when I take sum to 4 terms, n over here is 4. So I will be having 2 into 4 square, which is 16, which gives me 32. Now I have the sum of the AP up to 5 terms, which is 50, and the sum of the AP up to 4 terms, which is 32. The difference between these two can only be the fifth term, correct? After all, what I'm doing, I'm adding every consecutive term with the preceding term, summation of the preceding terms, so that I get the sum up to n terms. So if I want sum up to 2 terms, I'll add A and A plus D, I'll get 2A plus D. If I have sum up to 3 terms, I'll have to add A plus D and A plus 2D. Like that, I'll be adding every next term to get sum up to the n terms. So sum up to 5 terms minus sum up to 4 terms will give me nothing but the fifth term. So T5 is equal to S5 minus S4, which gives me 50 minus 32, which is nothing but 18. Okay, 18 is the answer. I hope this is clear. Now let us proceed to the next sum. The next problem that we have is, okay, next problem. The sum of 3 numbers in a geometric progression GP is 28. When 7, 2 and 1 are subtracted from these numbers, okay, subtracted from the numbers first, second and third numbers respectively, Okay, in the same order they are being subtracted. 7 is subtracted from the first term, 2 is subtracted from the second term, and 1 is subtracted from the third term. Then the resulting numbers are in AP, arithmetic progression. Here comes the actual question. Now they are asking us, what is the sum of squares of the original three numbers? Original three numbers. What is the sum of squares of the original three numbers? Okay. So let us look at the question again. They have given us, there are three numbers, okay, which are in a geometric progression. The sum of these three numbers is 28. When we subtract 7 from the first number, 2 from the second number, and 1 from the third number in that precise order, we are getting three resulting numbers which are in an arithmetic progression. Now, what is the sum of squares of the original three numbers? This is what has been asked from us. Now, let us see here. I am going to take the first number as a divided by r, the second number as a, and the third number as ar. Okay. Since the numbers are given to be in geometric progression, we know that, okay, Tn in a geometric progression is given by a multiplied by common ratio whole power n minus 1. Okay, so instead of starting the first term with a, I am just going one step before by taking the first number as a divided by r. Okay, that is a into r power minus 1. Then I am coming to a and then to ar. Okay, this is the geometric progression that is there. Now what happens, they have said that when I subtract 7 from the first number, 2 from the second number, and 1 from the third number, okay, in this precise order, I will be getting an arithmetic progression. A by r minus 7, a minus 2, and ar minus 1 is in arithmetic progression. What does that mean? It means that they have a common difference. The difference between the second term a minus 2 and a by r minus 7 should be equal to the difference between ar minus 1 and a minus 2. So that is what it means. There is a common difference. D is equal to a minus 2 minus of a by r plus 7. Okay, minus of minus 7 becomes plus 7, which is again equal to ar minus 1, which is the third term, minus the second term a, and minus of minus 2 is plus 2. So we have these values here. Now I simply have to simplify this equation. Okay, so a minus a by r plus 7 minus 2 is plus 5 equals ar minus a plus 2 minus 1 is plus 1. Okay, now I have to take all the terms having a on one side and the constants on the other side. Okay, so a minus a by r, this ar, when I bring it to the left hand side, it will become negative, minus ar, and this minus a, when I bring it to the left hand side, it will become positive, plus a, equals 1 is already there, positive, plus 5 when I bring it to the right hand side will become minus 5. Now I have to simplify. Okay, this gives me so that gives us 2a minus of ar plus a by r is equal to minus 4. Now we know that, okay, they have given in the question that the sum of the three numbers, original three numbers which were there in the geometric progression is 28. That is, we took the three numbers as a by r, a, and ar. When we add them together, we are getting 28. This is what was given in the question. Now, look here, if I have to take AR plus A by R, only these two terms, okay, AR plus A by R, then it would give me 28 minus A. I'm doing nothing but taking this A to the right hand side. So I can substitute this over here. A divided by R plus AR gives me nothing but 28 minus A. So 2A minus of 28 minus A yields me minus 4. Now, so to simplify this, I'll be getting 2A minus 28 plus A is equal to minus 4. In other words, 3A is equal to minus 28 when taken on the other side will become plus 28. So plus 28 minus 4 is 24. So this implies A is equal to 24 by 3, which is nothing but 8. So once I have A, I can simply substitute it over here and I'll be getting the other two terms. Okay. So I have 8 by R plus 8R is equal to 28 minus 8. So that gives me 8 into 1 by R plus R is equal to 20. Or in other words, 8 into R square plus 1 divided by R equal to 20. Okay, common denominator is R. Okay, so 8 into R square plus 1 equal to 20. That would give us 8R square plus 8 equal to, cross multiplying the R from denominator on the left hand side to the numerator on the right hand side would give us 20R. So this is what we have as a quadratic equation. Okay, makes sense. Because when we look at the common ratio for this geometric progression, it can work both ways because three terms are there. It could be an incremental ratio or it could be a decremental ratio. Both ways it can work. So R will have two values. One of the values will be the reciprocal of the other. Both ways it can work out. Now, we have the quadratic. Now, we have the quadratic equation 8R square plus 8 minus 20R equal to 0. Okay, we need to find the roots of this quadratic equation to find the value of R. For this equation is of the form ax square plus bx plus c equal to 0. We can simply use the quadratic formula minus b plus or minus root of b square minus 4ac divided by 2a to find the roots of this equation. As to how this formula is derived and how it works, I have already made another video. The link for which is provided in the description below. You can have a look at it. Okay. So now, if you look here, the value of a, which is the coefficient of r square here in this equation, is 8. The value of b is equal to the coefficient of r, which is minus 20. And the value of c, which is the constant, is plus 8. Substituting this in the quadratic formula, we are getting minus of minus 20 is plus 20 plus or minus root of minus 20 the whole square, which is 400, minus 4 into 8 into 8 divided by 2 multiplied by 8. So that gives me plus 20 plus or minus root of 400 minus 256 divided by 16. So that gives me plus 20 plus or minus root of 144. 400 minus 256 gives us 144. Root of 144 is 12 divided by 16. So this could give us two answers. 20 plus 12 divided by 16, which is 32 by 16 is 2, or 20 minus 12 divided by 16, which is 8 divided by 16, which gives us 1 by 2. See, I already told you the two values which we get for the common ratio R will be the reciprocals of one another, 2 and 1 by 2. Why? Because I can have it as an incremental geometric progression or a decremental geometric progression. Both ways it can work out. So if I take a is equal to 8 and r is equal to 2, we'll be having a by r is equal to 4, a is equal to 8 and ar is equal to 16. Or if I take a equal to 8, r is equal to 1 by 2, we'll be having a by r is equal to 8 divided by 1 by 2, which is 16, and a is 8, and ar is equal to 8 into 1 by 2, 4. Both these geometric progressions are valid for the given question. It can be a series of 4, 8 and 16, or 16, 8 and 4. Both are valid. Now, the question is, they are asking us what would be the sum of the squares of the original numbers. Now we have got the original numbers, we just need to square them up and add them. 4 square is 16, 8 square is 64, 16 square is 256. Adding them, we get 336 as the answer. This is the solution for the given problem. I hope this is clear. I hope you find the video useful. Thank you and have a nice day.